Hello guys, this is Sky Academy. I'm teacher Emmanuel. Today you are going to look upon the lesson of chemistry which is found in senior 4. Uh, this is the first unit. It's what you call discovery of the atoms constituents or discovery of subatomic particles. Yes. Okay. So, in the discovery of subatomic particles or atoms constituents, we have different scientists which worked on in order to have the structure of atom that we have and also to know about the atoms constituent. As you know, simply as subatomic particles, the main ones are protons, neutrons, and electrons. So we have different scientists who helped to work on that subatomic particles. So we have the first two, Democritus and John Dalton, which were trying to explain about what atom is. Then also we have those three, John Joseph Thomson, Rutherford, and James Chadwick, who contributed greatly the discovery of protons, electrons, and neutrons. Yes, simply the first one, this is one is Democritus. Um, this one, it is a great philosopher who lived 400 years before Christ. He suggested that matter can be divided into small particles up to an ultimate particle that cannot anymore be divided, and then he called that particle an atom. Simply, Democritus told us about the atom, but uh, he was trying to explain atom as an indivisible particle of matter, the final particle of matter, which cannot be either divided, but we will see that an atom can be divided because it has some constituents. So atom in Greek word, it is atomos, meaning indivisible. Yes, we have also the Dalton atomic theory. Dalton have also contributed in to know about many about atom. Here he said each element is made up of tiny particles called atoms. The atoms of a given element are identical. The atoms of different elements are different in some fundamental ways. So the chemical compound are formed when atoms of different elements combine with each other. The chemical reaction involves the reorganization of the atoms, the change in the way they are bound together. Simply, Dalton have proposed different theories. Those are the theories that of Dalton about atom. He said each element is made up of tiny particles. Yes, of course, element is made of atoms, but simply maybe we have different atoms of an element. For example, if you have a diatomic element, means it is made of different atoms of the same element. So the atoms of a given element are identical, the atoms of different element are different. Then the compound are formed when atoms of different elements combine with each other. Chemical reaction involves the reorganization of the atoms. So that is the theories proposed by Dalton. Then what I want to focus here today, it is here for the discovery of of electrons, of protons, of neutrons. Here, this person is called John Joseph Thomson. He discovered the electrons in 1897. Yes, John Joseph Thomson discovered the electrons. Then he made the different experiments that came up with the idea of the existence of electrons. So here he made an experiment with the gas discharge tube. The setup of gas discharge tube is like this one. As you see here, here we have this vacuum pump, but this is our container, a glass tube which have been evacuated in order to remove any kind of matter, especially even the gas. And also he take this container and then he connect it with a high voltage source. Yes, here. And also he connected two plates. One it is a cathode and another is an anode. And then this setup have brought after connecting the voltage to those electrodes. You see here in the middle there is what you call the cathode rays. Cathode rays were created by the movement of electrons. So the cathode rays they emit light, and then that light were moving from the cathode, which is negatively charged, to anode, which is positively charged. You may check it on this video. I don't know if it is going to be played, but yes, maybe I had a video which is not being played, but returning to our gas discharge tube, it emits some rays. And then the ray travel from the cathode toward the anode. The anode, simply that shows that those rays are moving from negative electrode to positive electrode. Means that we have negative electrode and also the cathode ray have negatively charged, so they make reparation by moving to the anode, which is positive. As you know, the negative move toward the positive or positive toward negative. But if you have negative, they cannot move in the same direction because they try to repel. They make a reparation. So the discovery of electrons is simply you have the gas discharge tube. Discharge rays originated from the cathode and move toward the anode, and hence are called the cathode rays. Using a luminescence technique, the cathode rays are made visible, and it was found that these rays are deflected away from negatively charged plate. Yes, those cathode rays are moving in the direction opposing the one of negatively charged. So simply this shows us those cathode rays possess negative charge, so they move away from the negative electrode. So the scientist J.J. Thomson concluded that the cathode ray consists of negatively charged particles, and he called them electrons. After discovery of electrons by John Joseph Thomson, he tried to propose what I can call a model of an atom. Yes, a model of an atom. And then he tried to put what he has already discovered, that is electrons. He created the model which is called the plum padding model. This is a plum padding model of electrons, where he postulated that an atom consists of a diffuse cloud of positive charge with the negative electrons embedded randomly in it. As you see this model, it seems to be like a plum pudding. To understand the plum pudding, you can use also this image here. Uh, this is a dessert, which where we have some kind of fruits here. Those are the fruits which are embedded in this dessert. Like, for example, you can call it a bread, but it has different ingredients. Then we embedded some fruits. Those kind of fruits that have been embedded in this dessert, you can compare it as electrons. And then, even though John Joseph have already discovered electrons, he tried to figure out how the model of atom might be look like. So he came up with this plum pudding model, where we have electrons which are embedded in a spherical cloud of positive charge. So that is the model of John Joseph about the atom and his discovered electrons. So we have another scientist who is called Rutherford. This Rutherford and his discovery of protons. Simply, Rutherford made an experiment also to prove the presence of uh, which are protons, positively charged particles, which are protons. So here he set up the source of alpha particles. Simply, the alpha particles were helium, which were which emit alpha particle. Then those alpha particles were directed at a thin gold foil. Those alpha particles were made to move in the direction where they are going straight to a thin gold foil, as you see here. And then around you have what you call a foil. Most particular, there is what you call a metaphor foil. Um, Sorry, this is a fluorescent screen. Yes, this is a fluorescent screen to detect the alpha particles. And then in the middle, you have what you call a metal foil or a thin gold foil. So then the alpha particles, um, as the as the model of John Joseph have shown, these experiments were supposed to bring those alpha particles in the same direction, moving in the same direction, and then maybe there would be some minor deflection, but what Rutherford seen was incredibly important. We are going to look upon in this figure. The expected result of metal foil experiment of Thomson model, they were supposed to see um, the straight rays, the moving of the rays in a straight line, um, according to John Joseph. But what you have seen is this one. He has seen also that many alpha particles were moving in a straight line, but also there are some other particles which have been reflected, others bounced back. These have a great meaning. What he has seen, most particles pass straight through the foil because atoms have large empty space. But also, a few were deflected at large angles, yes, and then some even bounced back. as you have seen, some deflected, there were some deflection, but also there is other particles which bounced back. This outcome was a great surprise to Rutherford. Rutherford knew from this result that Lamb plotting model for atom could not be correct. Yes, as you see here, Lamb plotting model cannot be correct because some particles bounced back. The large diffraction of the alpha particles could be caused only by a center of concentrated positive charge that contains most of the atom's mass. Yes, of course. If you have large diffraction or some particles are bounced back, means that in the center there is something which is dense. And what is dense here? It is the center, which is nucleus, of course, containing some protons. And then if alpha particles comes and then hit on the dense nucleus, those particles deflect back or bounce back. Yes. Then the conclusion: atoms mostly empty space. Yes, it has large empty space, but also there is a dense positively charged nucleus at the center. Yes, there is a dense positively charged nucleus at the center where alpha particles were hitting and then bounce back. Then the experiment showed that the dense nucleus there, it possesses a positively charged particles which are called the protons. Yes. So Rutherford showed that in the nucleus there is protons which make large mass in the center of the nucleus, and then it cause the diffraction or the returning back of alpha particles. Yes. Then we can look upon the discovery of neutron by James Chadwick. Simply, in spite of the success of Rutherford and his co-workers in explaining atomic structure, there were another major problem which have not been unsolved. What is that problem? We can compare, we have our periodic table which possess elements. For example, if the hydrogen contains one proton and the helium atom contains two protons, because if hydrogen has one proton, it is the first. The second, which is helium, also must possess two protons. But the problem comes, the relative atomic mass of helium is twice that of hydrogen. As you know, the relative atomic mass of helium is twice that, it is 4. However, the relative atomic mass of helium is 4 and not 2. It is, as we have seen, if in the center there were only protons, means that the protons should have or should possess the whole mass of the atom, almost whole mass, because electrons also have a very small mass, but for the protons they have large mass. But we may ask ourselves, if hydrogen has one proton, means helium should possess two protons, and then the relative atomic mass of helium should be twice that of hydrogen. Of course, should be twice. However, the relative atomic mass of helium is 4 and not 2. This question was answered by the discovery of James Chadwick, English physicist, who showed the origin of the extra mass of helium by simply bombarding a beryllium foil with the alpha particles. So this James Chadwick took alpha particles and then he bombarded them on beryllium Then what you have seen some uncharged neutrons, but some uncharged particles. Then those particles were supposed to pass in paraffin wax. This paraffin wax is simply made of some hydrogen, and then those uncharged neutrons were they had the capacity to bounce to knock. To knock off. I can say to knock off or to dislodge. When you say to dislodge, simply it is saying to try to displace. Those uncharged particles tried to displace the positively charged particles which were in paraffin wax, and then you get the positively charged protons. As you see here, the counter have showed the change. This change it is caused by the positively charged particles, means that those particles are created by the neutrons which bounce protons to the protons which paraffin wax, and then you see these positively charged. Simply those particles were uncharged because they are unable to be recorded here, but they are available. They have some kind of mass, and even the neutrons have slightly greater mass than the protons, so they are able to hit, and then they push some protons, and then you get a positively charged protons here. So simply, we can ask ourselves how neutrons were discovered. Alpha particles were bombarded onto beryllium metal, and then a new uncharged radiation was emitted. This radiation knocked the protons out of paraffin wax, a hydrogen-rich material. This paraffin wax is a hydrogen-rich material, so the neutrons or uncharged neutrons were able to hit paraffin wax in order to knock off the positively charged protons. So here, what we have observed, the emitted radiation had mass but no charge. So the radiation has mass but no charge. Simply denote the neutrons which do not have a charge but they have mass. Also, it could dislodge protons, so it had a significant momentum. Uh, because the neutrons has a significant amount of mass, they are able to displace or dislodge protons to try to displace them in their position. So the conclusion is the radiation was made of neutron particles called the neutrons, and then the neutrons are located in the nucleus and contribute to the atomic mass. So that is the Chadwick experiment. And then the mass of neutron is slightly greater than that of proton. So the figure we are going to look shows the location of the elementary particles, protons, neutrons, and electrons in an atom. So there are other subatomic particles, but electron, proton, and neutron are the three fundamental components of the atom that are important in chemistry. So you have different subatomic particles. There are many. They are not bound to three. But the most important are those three: electron, proton, and neutron. That's one we notice that is interesting, but also we look upon other particles when we reach senior 6. But for now, those are the subatomic particles we are looking upon, which are most important. So we can look upon how the figure of an atom, simply the atom possesses a very small dense nucleus, and then whirling around those nucleus, is a cloud which is made of negatively charged electrons. And then this nucleus is made of protons, the positive charge, and the neutron, which is have no charge. Then this nucleus is the one which possesses almost the amount, the mass of the atom is made by this nucleus. So this figure, the proton and neutron in an atom are contained in the tiny volume of the nucleus, though electrons are distributed within the sphere surrounding the nucleus. So atoms consist of very small, very dense nuclei surrounded by clouds of electrons at relatively great distance from the nuclei. So, as you see, we have seen how the subatomic particles are disordered. Maybe I think this is enough. So, this is the end of our session. We shall meet in the next videos. So, thank you for your kind attention. I want to remind you that you may subscribe so that other videos may come, and then you be the first one to watch. So we shall meet in the next sessions. So goodbye.